Welcome to lesson 47 of the 7th grade of course 2. That's what we want to call it, course 2. As we look at course 2, of course, our lesson for today is focusing on powers of 10. Though, in general, it's going to highlight a big idea that we can learn from powers of 10, and most of our practice will then be working with powers of 10. In general, we know what an exponent is. We know that to look at an exponent by itself, such as 2 to the second power, that really means 2 times 2. Right, so I take my base number, and that's where I get this number and this number from the actual 2's, and then the number of 2's that appear is here, right? I have 1 2 here and a second 2 here. And so that's what exponents, we have that basic relationship. Today we want to look at what happens when we start multiplying exponents and dividing exponents and the relationship that comes here. And that's where we come away with this really very simple formula to follow. It says a to the x, x being an exponent, times a, so it has the same base, to y, so it's a different exponent, a different number, is going to equal a, right? So the base isn't going to change. And in the end, I'm going to take the two exponents and I'm going to add them together. All right. So that's the general form that we can see here. And now let's apply that. All right. So we have the number 2 to the 4th times 2 to the 2nd. And we want to know, well, what does that equal? All right. We've already established that when I have our a, in this case it's a 2, right? And now I have the same base. I'm going to end with the same base. So from here I want to say, okay, so I'm going to end with the same base. All right, what's going to happen next? All right. The real math comes with our exponents. When we're multiplying two numbers with the same base that have different exponents, in the end, I'm going to add those exponents together. And that's what's highlighted right here. So 4 plus 2 equals 6, and I come away with an answer of 2 to the 6th power. And we could prove that by saying, okay, well, 2 to the 4th is 2 times 2 times 2 times 2, right? 4 2's. And 2 to the 2nd is 2 times 2. And so really we have 2 times 2 times 2 times 2 times 2 times 2, which of course equals, right? There's 2 is our base. There are definitely 6 2's in front of you there. And so we have that understanding. Go ahead and try this sample problem then and see if you can determine what 10 to the 9th times 10 to the 3rd equals. From here we move on to the next concept, right? A to the x divided by y, a to the y equals, right? Very similar to, right? Since multiplication and division are opposites, we're also going to use an opposite operation. First time when we were multiplying our exponents, we ended up adding them together. Now we're going to subtract them, right? So we come away with this idea, right? Let's take a look at this in the problem below. It says 2 to the 4th divided by 2 to the 2nd, right? So literally that would look like 2 times 2 times 2 times 2 over 2 times 2. Right? And so we already know I could start canceling things out like this, and I should get an answer of, well, 2 2's, so I should get 2 squared for a final answer. Now what does that really do? What did I really do here? Right? Took a base of 2, base of 2, base of 2 stays. From there I say, okay, 4, 2, division of exponents means subtract 2. 4 minus 2 equals 2, and our answers are agreeing then, right? So once again, use this formula to solve this problem. The third scenario that we have here is what's called a power of a power, where we have a to the x to the y power. All right? And when this happens, suddenly we have a new phenomenon. We have a to the times a to the x times y. That's what I'm trying to say. Spit it out. Spit it out. There it goes. And what that would look like is a problem just like this, right? 2 squared to the third power. Now, if we think about what that is literally saying, what that's literally saying is we're going to take 2 squared times 2 squared times 2 squared. Right? And we just learned that when we're multiplying exponents, it's like adding them, right? So 2 plus 2 plus 2. Now, if you look at 2 and 3, and you see an answer of 6, you're going to say, wait, I know a relationship already. That's multiplication. 3 times 2 is going to give me the same base and an exponent answer of 6. And we can show that again because we could break this whole idea down and we could write 2 times 2 times 2 times 2 times 2 times 2, right? And once again, we see 2 to the 6 coming out that way also. And so we have this third idea that we want to understand when it comes to exponents. All right? All right, here's your sample then as you work with powers of 10. Right? 10 to the third times 10, sorry, to the 6th power. 10 to the third to the 6th power. All right, that information was the new information, or the newer information. From here, we want to just really distinguish, making sure we have the idea of how powers work in general, especially powers of 10. So if I have a problem like this, it says 46 and 235 thousandths times 10 to the second, what is the actual number I'm trying to look at here? What is the real number, right? And from here, we get into some of our tricks, right? First of all, we have to understand what is this number. Right? 10 to the second, of course, is 10 times 10, so it's 100. Remember, with powers of 10, that 2 really represents how many zeros there are. All right, 2. Now that understanding of how many zeros there are is going to be important because it's going to help us to move the decimal point. Because when it comes to multiplying by a power of 10 or by 10 or by 100 or by 1000, those number of zeros, or in this case the exponent, tells us how many place values to move our decimal, either to the right or to the left. In this case, we're going to go to the right. When we multiply, we move to the right, right? Our numbers grow. They get bigger when we multiply by 10. So when I multiply by 10, I'm going to look here. I see an exponent of 2, which means I'm really multiplying by 100. And we know that when we multiply by 100, we move it to place values. So our final answer is 4,623 and 5/10. Right? So we have this idea. I'm realizing I made a mistake in my lesson. I want that to be a division symbol. Right? Division, of course, works in the opposite way. So instead of moving the decimal to the right, we want to move the decimal to the left. But once again, what it stays the same is that this idea helps us understand what's going on. Now 10 to the fourth is 10 with 4 zeros behind it. So it's that idea. So what is 3.5 divided by 10,000? Well, you could sit there and you could plug it in into boxes and try and move it, but because it's a power of 10, we can just start moving the decimal to the left now. So as we move it to the left, we can say, okay, let's move it to the left. 1, 2, 3, 4. Right? And after I do that, I can reestablish my new number. 1. And in the end, I get an answer of, right, 35, right? Tens, hundreds, thousands, 10,000s, 100,000s, 35 100,000s. Right? So these concepts look a little new because we have some powers there, but the concepts of moving decimal places by powers of 10 is just a review. So slightly bigger numbers, maybe a few more decimal places to move. All right. Finally, as we end this lesson, I want you to look at thinking about, well, how would you take a number with a label like billion and write it in 2 different forms? First of all, write it with scientific notation. All right. We could talk about this idea of expanded notation, so by its place values, right? So that's kind of like this, this, and then you have the multiplication side, and now you have the powers of 10, whatever they may be. Remember that? Good, because that's good. All right, and then in standard form, that means write it as a number, right? With all the zeros and whatnot involved. That's lesson 47. That's lesson 47.